Hello student. So in our last class we have discussed about the different term which is related to circle like tangent, secant, radius, chord, etc. etc. And today we will discuss about the theorem 10.1 of your book. And what does this theorem says? This theorem says that the tangent at any point of a circle is perpendicular to its radius through the point of contact. So hope you know what is point of contact. I have already told you. Again I want to repeat it. कोई एक सर्किल ले जाते हैं, मान लो ये एक सर्कल है और ये एक टेंजेंट है, तो जिस पॉइंट पे टेंजेंट सर्किल को टच करता है, यहाँ पे इंटरसेक्ट करता है, दैट पॉइंट इज नोन एज आवर पॉइंट ऑफ कांटेक्ट. सो ये थ्योरम ये कहता है कि अगर हम एक टेंजेंट ड्रा करते हैं तो टेंजेंट क्या करता है, जो रेडियस होता है, यहाँ पे देख सकते हो OM रेडियस है. सो द टेंजेंट इज परपेंडिकुलर टू दिस radius through the point M. So, and we have to prove this theorem. So first we have to write the data that is already given to us. So, given that here the center of the circle is O. PQ is the tangent which intersect the circle at point M. Here OM is what? OM is radius. So this is the data given to us. What the data says? It says this is a circle with center O and the line PQ is the tangent to the given circle which intersect the circle at point M. And here we can also notice that the length OM is the what? Is the radius. Now this is the data given, and what we have to prove? We have to prove that OM is perpendicular to PQ. It means this radius is perpendicular to PQ. You can say that, sir, here it is written as the tangent is perpendicular, and obvious, if the radius is perpendicular to tangent, then it is obvious that tangent is also perpendicular to the radius. Perpendicular means what? Perpendicular means if the angle between two lines is 90 degrees, then we can say that the two lines are perpendicular. So we have to prove that this line is perpendicular to this line. If the shortest distance between two lines is the perpendicular line. Okay. So this is the fact. You hope you all are known about this fact. So now we have to prove. Before that, we have to construct something. Construction. let's take a point what, x on PQ, so that and PQ join OX so that it intersect the circle at point y. Okay, so here let us, what we have to construct, we have to take a point x on PQ. Let this is x. Now we have to join OX. What we have to do? We have to join OX. So I have joined here. I join OX. Sorry, my line is not that much straight. So let's try to make it more straight. So here OX is the line, we have to join OX, and we see that OX intersect the circle at point Y. This is what is our construction. Now we have to prove. Let us start. So in this case, here we can see that OM is equal to OY is equal to what? Radius. You can easily notice that according to the definition, the distance from the center to the circle is known as our radius. So this is radius. Distance from the center to the circle is known as our radius. This is also our radius. So obviously the radius are equal. So OM is equal to OY. Now just you think, if OM and OY are equal in length, then it is obvious that OX will be greater than OM. Yes or no? So if OY and OM are equal, then it is obvious that OX will be greater than OM. So I can write here, hence OX is greater than OM. Now if OX is greater than OM, then you can imagine this situation for any point on PQ apart from M. You just imagine any point on PQ and just imagine that you are going to draw a line or joining the line to the particular point that you have imagined to the center. Then the line you got will always greater than OM. मतलब कोई भी एक पॉइंट अगर तुम यहाँ पे इमेजिन करते हो और उस पॉइंट को O के साथ जोड़ देते हो, तो जो लाइन तुम्हें मिलेगा हमेशा क्या होगा, O OM से क्या होगा, बड़ा ही होगा. It means OM is the shortest distance from O to PQ. Yes or no? And I can write here, this will happen for any point on PQ apart from M. So OM is the shortest length, hence OM perpendicular to PQ. Proved. अभी फिर से मैं दोहरा देता हूं, M के अलावा अगर कोई भी पॉइंट हम PQ के ऊपर लेते हैं तो क्या होता है, वो लाइन, जो भी लाइन हमें मिलेगा वो पॉइंट के साथ अगर O को हम ज्वाइन करते हैं तो वो लाइन हमेशा OM से बड़ा ही होगा। इट मीन्स OM is the shortest distance. As I have told you before that the shortest distance from a point to a particular line is always perpendicular to the line. Hence OM perpendicular to PQ. This is what we need to prove, and we have to remember that the tangent is always perpendicular to the radius. This is what the theorem 10.1 says. So now we jump to the next concept of this chapter, that is number of tangent to a circle. मतलब एक सर्किल के ऊपर कितने सारे टेंजेंट ड्रॉ किया जा सकता है, एंड दैट टू अलग अलग जगह से। जैसे कि यहाँ पे एक सर्किल मैं ड्रॉ कर चुका हूँ, एंड दिस इज अ सर्किल, यू कैन सी, एंड दिस सर्किल हैव 3 डिफरेंट पार्ट्स. वन इज दिस पार्ट इज नोन एज आउटर साइड और आउटर पार्ट ऑफ द circle, and this is known as inner part of the circle, or inside the circle, outside of the circle, and this is this part, this circumference is known as on the circle. So I just want to know, or now we'll discuss that how many tangent can be drawn from this different part of the circle. So first let's to take the inside part of the circle. Suppose this is a point P which is inside of the circle, and now I just want to draw a tangent from this point P. So I just draw this line like this. So it intersects the circle at point X, but when I extend the line through this direction, I can see that it also intersect the circle at point Y. So what I got that this point P, if I want to draw a tangent from this point P, it is quite impossible, because the line will intersect the circle at 2 different points. So from any direction you just try, from like this, like this, like this, like this, what you will get? You will get that the line intersects the circle at 2 distinct points. It means we never get a tangent from a point inside the circle. एक सर्किल के अंदर से हम कभी भी एक टेंजेंट ड्रॉ नहीं कर सकते हैं. This is case 1. Case 1. Now let us take this circle. So this is the point P. Now what will happen if I want to draw a tangent? Then it will pass through this. This is the tangent, and if I try to draw like this, as I have discussed in my first class of this chapter, you can notice that from a point on circle we can draw only one tangent. As I have discussed before, we have already known to the fact that the point on a circle, from a point on a circle we can only draw a tangent, only a single tangent to the given circle. मतलब सर्किल के ऊपर जो पॉइंट है, सर्किल के जो पॉइंट है, सर्कमफेरेंस के जो पॉइंट्स होते हैं, उस पॉइंट से हम टेंजेंट के ऊपर सर्किल के ऊपर एक ही टेंजेंट ड्रा कर सकते हैं. मतलब इनसाइड ऑफ द सर्किल से 0 टेंजेंट, ऑन द सर्किल से 1 टेंजेंट. अभी ये है मेरा केस 3, ये केस 2. केस 2 याद रखना आराम से. ओके, केस 1 नो टेंजेंट, 1 टेंजेंट, 1 tangent. Now in this case, suppose this is the point P. You can see that I can draw a tangent in downward direction. Also I can draw a tangent in the upward direction. This is Q, this is R. In this case, how many tangents are there? 2 tangents. What we can conclude from these three cases? From these three cases, we can conclude that from the area lying inside the circle, we can draw no tangent to the given circle. From the point on the circle, we can draw only one tangent, and from a point which is outside of the circle, we can draw two tangents to the given circle. So, this is the cases. If someone asks you how many tangents can be drawn from the outside of a circle, then you can say two tangents. If someone asks you how many tangents we can draw from the inside of a circle, no tangent. If someone asks you how many tangents can be drawn from a point on the circle, only one tangent. This is the cases. So, this is what we have learned in this chapter. Next class, we will discuss another theorem, then we will solve few problems. So, for today, this much only. Thank you.